Hi and welcome to Tyrolit Tool School on location. As you can see, we are not in our normal TV studio in Schwalz in Austria. No, today we are in northern Italy in Piedmont, Margherita, where we have our production on all surface conditioning material, our unitized discs, convolute wheels and stripped material. So now I'm gonna move inside to our mobile TV studio and I'll see you in a bit. Good morning and welcome to Tyrolit Tool School on location, as we said before. So we are here now in our mobile TV studio in the northern part of Italy. This is the location where we manufacture, produce all our surface conditioning materials, our unitized discs, our convolute wheels and our stripped material. As you can see, I am not alone. I have with me my friend and colleague Luca Goletto, who is the head of product development and quality control here at the facility. So,
hi Johan, welcome.
Well, thank you, Luca. Thank you very, very much. It is a pleasure being here. Thank you for the hospitality you already shown us, the help you already given us, and also thank you for being that we can be here. When I say here, I mean we are here at the birthplace of the newest CERABOND X family member, the CERABOND X unitized disc. It's a completely new thing. It's the new family member in this group. So we have this new ceramic grain, we have this new bonding system that we have here. But before we continue on that, we want to show you how we get to that, what elements are necessary on production side. So first of all, we're going to show you a video that we shot yesterday on the production to make you clear what we're talking about here. So the first important element is the pellets. Nylon pellets that are going to be transformed by a form of extrusion. They're heating up, then extruded throughout the system, cooled down in a very specific way, which is also patented. Then the whole thing goes through that. Now, what is very important is, because of all this, we can determine a lot of elements on that fiber, the elongation, the size, the crimp. We can play with that. And because we can play with that, we can actually develop fibers for specific application, specific products, and get the best result out of that. And this is unique. We are unique on that. This is the last step where the fibers are being shredded, which you will show now. You see the wool. Yeah, this is a great shot. Thank you, Michael. Great shot. Excellent. Brilliant. So we get that. So to summarize that very quickly, these are the pellets that we're talking about. So these are those things here, as you can see in the close-up. As that, it's a nylon pellet that is transformed, and we are getting to those fibers. This fiber now is a 6.6 fiber, which is a quality label, I would say. Yes, so quality label 6.6. Now that fiber we're going to transform into this. So we're going to create a very large roll of this material. So the fibers brought together like that, a thin roll, a large roll with thin material like this, where we're going to put on a resin and the grain. So this complete roll is going to be looking like that during the production, which we're going to show you now how we continue on this. So we continue with the production on the unitized discs. So you can see that those sheets, now they're transformed from the roll to the sheets, are layered on top of each other. So according to the density, more or less sheets are being used. Then finally, we're going to put on there a steel plate, a slab. Then we're gonna press all that together. So you see the thickness of those layers, how much material is on there, and this is now gonna brought down to the size it needs to be, to the thickness it needs to be. How much ton are we having on that press?
18 tons.
18 tons weight pressure on that. Look at that. Transformed like that, all completely done. Now we're gonna lock that up with the steel bars so that it can't move anymore. Then it's gonna be put into the oven. It's gonna cured over so much time, and then finally we end up with the result that we'll show you in a minute. So this is in a nutshell how we manufacture our unitized discs. So we start with the fiber that we make, ending up with the discs that we make. And this is all done here. Is that correct?
Yes.
That is correct.
Absolutely.
Excellent. So where do we end up with? We end up with a slab like that. This is what we're having. Different thicknesses. Oh, there we go. I'll show you like that. There we go. Different thicknesses. There's the more one with. There we go. This is basically the material that comes out of that press when we're done with it. So look at what is now the main difference. What has changed from the previous quality generation to what we have now?
Is the abrasive. This abrasive is a ceramic grain. This is a new type of abrasive, and the new resin make unitize more long life and with high removal rate than the standard one.
Okay.
Propeller is the name.
The propeller
grain.
Why does it's named propeller? Is it because
It's the form. It's the form of the abrasive.
Okay.
Yep.
So we're gonna. I can't now. We don't have a microscope here, unfortunately, but we're gonna try. I've taken the coarsest one we have. I'm gonna try to show you a little bit that you have an idea. This is basically what we're talking about. The grain is really shaped as a propeller, broken down into the different sizes that is necessary for the different unitized wheels. And because of that propeller shape, you have a cutting edge on every side of that grain. So it will lead to a performance that will excel on stock removal rate and on the lifetime. So you do get more material removal, faster material removal, and a longer lifetime because of the resin system that has been used to make that. So this is also less heat, right?
Yep.
Get less heat
Yes.
development during the work, and it will allow you to work faster. So your process time will be less in comparison to the use of the previous generation. So we have now, in this kind of quality, we have now a 6
Medium.
medium, and we have a 9
Coarse.
coarse. So two different densities, a 6, that would be this, fairly flexible. It's stiff, but it's still fairly flexible. And if you go to the 9, that's very hard. Now, that 9 is new, isn't it?
Completely new. Yes. Is for deburring and finishing in one shot.
Deburring, we train on this one. So deburring and finishing in one shot. So that means you have it aggressive enough to remove material, and at the same time it will give you a great finish. So this is kind of wow. This is great. As Lucas said, one shot. So this is what the product can do with the 9 course and as a performance. So look, I'll be. We know each other for quite a while,
Yep.
a long time. I know you're pretty excited about this.
Absolutely. This product opened up a new ways of creation that were impossible 10 years ago.
Right. So with the with this new development, you were
Yep.
possible to develop other qualities, new qualities,
Yep.
and that wasn't even possible 10 years ago.
Yep.
Wow. That's
Yes.
cool. That is really cool. So it means this is like a milestone, like a first big step
Yes.
in further development. That is pretty, I must say, it's exciting. Even I am excited about it. So this is also the first introduction of the range open to everybody. So this is a big step now. So the product is going to be available and it's going to be interesting to work with it, to try with it. Now, when we talk about applications.
Yes, but food industry, pharmaceutical industry, industrial knives.
Yeah. So also turbine blades. You can go to surgical, medical instruments or equipment. Handrails, guards. Let's go to the ship industry. I don't mean like shipyards where you have the big container ships. No, I mean yachts. Yachts, luxury yachts, where they have a lot of stainless steel. And this is the word that I wanted to use, stainless steel.
Stainless steel.
Stainless
Yes.
steel, because that's what they all have in common, is stainless steel. Stainless steel that's going to be treated, worked upon, even prepared or preparation to a mirror finish. So these are all elements where on stainless steel, that's where these products will excel. They will be great. Also, of course, not to forget, exotic alloys.
Yes.
There we go. So this is basically quite cool. Now, another thing, the sizes. What do we have on sizes? We have the discs for a straight grinder with a bore. There we go. That can be 50, 75 millimeters. We can have the discs for the quick change. Again, 50, 75 millimeters. We can have the discs for a fillet weld grinder, 152 millimeters or 6 inch. We can have also, of course, the discs for the regular angle grinder. We have all those materials. We have in thicknesses of 3 millimeter, we have 6 millimeters,
And also 13 millimeters.
13 millimeters. So according to the application, according to what is required, there are the different thicknesses available. Of course, the 3 millimeter on 152 millimeter disc, like we have here, is of course much more flexible in comparison to a 6 or a 13 millimeter, depending all, of course, on the application. Another thing that is quite important to say is concerning speed, the operating speed on the machines. These are not products that should be used at the maximum speed of the machine. When a machine runs at 11,500 RPM on an angle grinder, you don't want to use that with that product because it's going to be overheating it. It's going to be overheating the workpiece itself, and it doesn't bring you anything. Just it will wear it down faster. You will not speed up your working process. You will not speed up the finish. It doesn't work like that. This is something where you need to drop that speed to, I would say, if the maximum is 11,500, drop it to 5,000, 6,000 RPM, and you're absolutely right.
Yeah.
Am
Absolutely. Yes.
So this is a tip from professionals. So there you go. So we've been talking quite a bit now,
Yeah.
or especially me. I've been
Start.
talking let's start to do some work. Let's start to do some work. The first thing that we want to show you is on the small mini angle grinder, on the removal of the welding seam we have here on this tube. So what I'm going to use on that one is just this medium, 6 medium. On that, thank you, Luca. So, as I said, the speed reduced to about 9, 10,000, 11,000 RPM, absolutely fine. And removing that without overheating it. Let's see how that goes. So, welding seam is gone. Finish is nice. Even the scale from the stainless steel, the pitted material from the stainless steel has been removed and gives you a nice shiny finish. It's not a mirror finish, but it's a preparation too. So this is what you get with something like that. Now, another part, because we want to overdo it a little bit. So overdoing it is meaning we want to show you how far we can go with this kind of product. So what we have here is a bit of steel. I know we talked about stainless steel, but I wanted to show you this. This is cut by laser, but it's not really done nicely, so you have a lot of burrs on top of that. On this one, I'm going to use the 9. The 9 course, the hardest one we have, with the coarse ceramic grain in there to remove that and see how that works. This is demanding. This is not an, because this is sharp. So we're going to have a look at the disc after that, see how this works as well. As you can see on the disc, there is no damage, the burr is gone, no overheating, and the edge has been broken. So that's what this can do. This is powerful. This is impressive. This is powerful. You can't do that with anything. This is impressive. So that's what I wanted to show you on that. Overdo it a little bit to make you see how this actually can work. So the next part we have is for the fillet weld grinder, where we're gonna remove the welding seam in there. Again, we have the 9 on there, which is fairly hard. Looking at this welding seam, we actually might even work with the 6. The 9 is on there, so I'll do it with this one, but the 6 would be also absolutely fine to do that. As you can see, weldings have been gone. The structure, that wavy shape has been gone. I even need to be careful because it's the 9 course that I'm not going too aggressive, too fast, because it will gouge in. So that's the reason why on this one, the 6 would have been a better choice. But you can see how he works. This is pretty interesting. So now also, one of the things that I tell you is, in this case I've used the 3 millimeters. This is great, cool. But if you don't have the 3 millimeter available, you might actually use the 6 one, put it on the machine, and trim it with a fiber disc. For instance, I have here a 36 fiber disc. You let the machine run, you trim it, and you actually create a smaller thickness or preparation for that specific part that you want to go at. So this is also a possibility that you have using a fiber disc in order to trim your disc when it's too thick. You can't reach the part that you want to really dress and work with that. That's a possibility you have. Now we're getting to the normal angle grinder. Again, we're going to try, or I'm going to try to overdo it a little bit. We have the welding seam on the stainless steel here, the stainless steel box, which is actually quite a bit of material that we want to remove with the 9. There we go. Again, an angle grinder with a variable speed, brought back to about half in order to do that. So, welding seam gone, no gouging on the workpiece itself, no burning marks or overheating of the workpiece. So this is what is possible with a disc like that. This is what you can do with it. And this is quite impressive because that is a lot of material that has been removed. Now, we also, thank you, we also have the 6. And the 6 we can do a bit more lighter work. Still, take off quite a bit of material. There we go. Thank you. So in this case we have a round stainless steel tube with a big fat welt on that edge there. There we go. That you can see there. So this is basically what I want to remove, but without changing the structure, the geometrical structure of that tube. It needs to stay round. Live pressure. Done. Welding seam is gone on that end. Nicely still round. No overheating marks whatsoever. And also if you look at the wear of the disc, there's nothing. So this is basically what we wanted to bring to you, is that new development, that exciting development with the CERABOND X unitized discs. I must congratulate Luca because he's done an amazing job doing that. Also the grain, the resin, the whole thing, absolutely well done. So anyway, thank you very, very much for being here on our Tyrolit Tool School on location. Luca, once again, thank you for having us here and helping us here. And we are looking forward seeing you next time at Tyrolit Tool School. Thank you for being here and all the best. Cheers.
Thank you. Cheers.
Bye-bye. Ciao, ciao.